Okay, so we're off and running, recording. Welcome. It's election day, so got your vote in, and others may filter in just because of the voting lines or whatnot. I'm always marveled how the precincts work because my precinct is long, while the one right next to me is always short. So anyway, uh, so as we kind of look ahead, kind of a reminder, tomorrow you're going to have another test. And just a reminder there, it's going to test upon, where are we at? Is it this? It's this right here. So the square root theorem, 2.R.2, all the way down to section 1.9, testing the square root theorem, solving quadratic equations by way of the factoring method, quadratic formula, looking at some operations on polynomials and working with radicals and rational expressions. So we'll do some review, before we conclude here tonight. You're not going to see the test until a little later because I have to make it still, but it should pop up here, probably what? Well, that was test two. So it'll probably pop up, like right here or something like that pretty soon. So just to kind of give you a heads up of things. Okay, so let's press forward, at least in the first part of the meeting here. We'll press forward with the Cartesian coordinate. We were on 2.R.5, kind of taking a look at that, but we're going to move over to 2.3 and 2.4 here as well. So let's see. I think we're pretty much done with this one as far as I remember. Let me see. Yeah, we were. Okay. So we'd actually finished it. So we're good. So let me actually go back. And then let's take a look at what is it? Bear with me. Let's scroll down pretty quick. 2.3, and then we'll do 2.3 and probably then start on 2.4 after this. So we're getting into, so the fundamental thing with the first two parts of this was, what is an ordered pair? How do you plot an ordered pair to make a dot on the Cartesian coordinate system? How do you read the Cartesian coordinate system? And then the other thing was the notion of um, the distance formula, which is basically just the Pythagorean theorem. So that's sort of what you're having to deal with here. So the first thing here now, these two lessons that we're going to do here, 2.3 and 2.4, deal with what we call the equation of a line. And let me kind of just generally speaking, what are we doing here is we're going to be dealing with equations. There's two different formats that we'll look at it. You don't have to take notes on this yet. We'll do more as we go along. But one form would be what we call ax plus by equals c. This is what we call the standard form of the equation. Actually, let me do it that way. Let me do it that way. Do this. We have the standard form, which is of the form ax plus by equals c, where a, b, and c are actually numbers. Then we also have the slope-intercept form, which is of the form y equals mx plus b. And essentially what we have here, the takeaway from this is that we're going to be dealing with equations, and they're going to be we want to first identify whether they're equations that will result in a line or whether they're equations that will result in some other shape. And so generally what you're looking for, the way that you determine whether something is going to create a line in what we call a linear equation is take a look at the exponents. Excuse me, take a look at the exponents. What's the exponent over the y in each case? And what's the exponent over the x in each case? Let me throw it to you all. What are the exponents over the x and the y? Just from our knowledge of exponents. Any takers?
Is it 0?
Well, remember, if it's there, there's at least one of them. There's at least one of them. So when we have something like y equals mx plus b, I'm going to come over here. I can't type on that. I can't write on that thing. So if it's there, there's at least one of them over there. A zero exponent, remember, a zero exponent reduces down to 1. So if it's there, there's at least one of them. So in this case, the exponent over the x and the y is 1. If there's anything else, we have to tell you what the exponent is. 2, 3, 4, 5, whatever it is. So essentially, To be a linear equation means that the exponent over both the y and the x are 1. Anything else other than 1, it is not linear. Not linear, okay? So when we take a look at this one up here, uh, can we tell right away whether it's linear or not? You just look at the exponents of the x and the y, and what we see is the exponent over here is 1, this one is 1, and this one is also 1. So it indeed is linear. The other thing they want you to do is they want you to get it into the form. This is what we call standard form, ax plus by equals c. So in other words, what they want you to do is they want you to, hold on just a second. Okay. They want you to basically get rid of the parentheses and combine like terms. But the other thing is the x and the y are on the same side of the equal sign. That's the defining feature of the standard form, is that the x and the y variables are on the same side of the equal sign. So how am I going to clean this one up? How am I going to get this one to look like this form? What would we do? What would we do? Well, first we have to get rid of the parentheses. So how are we going to get rid of the parentheses here? Any takers?
We're gonna simplify it.
How? How do we get rid of the parentheses here?
We'll multiply the 2.
Mm-hmm.
2 times y is 2y plus 2x.
Yep. So take that 2 and apply what we call the distributive property. So we have 3x, multiply that 2 inside, multiply that 2 inside, so we get 2y plus 2x equals 4. Good. Now that we have the parentheses gone, we have to combine the like terms. So here's a like term and here's a like term. So we combine those to get what?
5x
Mm-hmm.
plus 2y equals 4.
Yep. So that's what we mean. We want the x and the y on the same side of the equal sign, no parentheses, combine like terms where we can. So that's what goes right here, is 5x plus 2y, oops, equals 4. And it is linear. It is linear. Why? Because the exponent over the x and the y are both 1. That's what it's going to create a line for us. So let me pause here. Any questions on that? It is linear, by the way. Any questions on this process?
So to do the standard form, does it have to be linear, or it could be not linear?
Yeah, standard form for our purposes here does mean, in this context, does mean linear.
Okay.
Now, it doesn't always, they're telling you the form they want you to put it in. Okay, so it was sort of a giveaway that it's linear, but they may not always say that.
Okay.
Okay, so let's press forward. Oops. Okay, so determine if the following is linear or not linear. This one, the curious thing is our exponents are still 1, okay? But at the end of the day, what do we have going on? What's the problem here? Is we have the x and the y in this case multiplying. So then what's the degree? What's the degree? When you have x, y multiplying each other, that's going to create something that is not linear. So what you need, and so what we're doing is we're building the criteria. In order for it to be linear, the x and y can only have exponents of 1, and the x and y cannot multiply each other. In an earlier lesson, you talked about the notion of a degree, the degree of a polynomial. Do you remember that in the last part of the material? The degree of the polynomial? Is that something y'all remember? Let me check in. Okay. So basically, a linear equation is when the degree is 1. Okay. So if I look up here, what's the degree? What's the degree? Back in that prior lesson, how did we determine the degree? Well, you look at each exponent, okay? So, but for this term right here, because the x and y are multiplying with each other, you take their exponents of 1 and add them together. So the degree of this term is 2, the degree of this term is 1, and the degree of this term is 1. So because we have a term with a degree of 2, that means that the entire degree is 2, means it's not linear. And so essentially what it boils down to is it's these two conditions right here. The x and y have to have exponents of 1, and the x and y cannot be multiplying each other. That's essentially the same thing as saying that the degree is 1. That's how you know when the degree is 1, is when you have those two conditions right there. The exponents over the variables are 1, and the variables are not multiplying each other. So let me give you one to kind of chew on then. Suppose I have 3y plus 2x squared equals 4. Linear or nonlinear? Not linear, right? Shaking your head, Jana? Yeah, I see it.
Not
Yeah. No, it's not linear. Why? Because
the
of
agrees
that
to.
exponent of 2. It kills it. It kills it. So good. Okay. So let me do another one. Do something a little more creative than just that. Okay. So let's do, I don't know, 4y uh, x plus 1 equals 2. Linear or not linear?
Mm, I would say not, because if you have to multiply 4y times x, you're going to get 4yx and have a degree of 2.
Yeah, you want to clear out the exponents. I'm sorry, clear out the parentheses. So we get 4xy exactly right plus 4y equals 2. It's the xy that kills it because they're multiplying each other. Okay, so that would also be not linear. One more. One more. Linear or not linear?
I would say not,
Why? You're right. It's not linear.
because you have 2x to the second power
So you're going to
plus 3.
multiply that 2x inside. Exactly right. So when we do that, we get 2x squared
Yeah.
plus 2x plus y. Uh-oh. This thing kills it right there. There's one more condition I forgot. One more condition. Okay, so are any questions so far? Any questions so far on what we're seeing? Why things are linear or not linear? The exponents have to be 1. They can't multiply each other. There's actually a third condition I forgot to mention. A third condition. Let's take a look at this one. What about this one? 2 over x plus y. If we were to use our rules of exponents, our properties of exponents, how could we write this by shifting the x up to the top? What's the rule that we would have to apply? A reminder is when you shift it up, you change the exponent, you change the sign of the exponent. So if we wanted to shift that x up to the top, we actually get 2x to the negative 1 plus y. The negative 1 kills it. It cannot be linear. Because remember, we need the exponents to be 1, positive 1. So what's the third condition? So remember, exponents over x and y must be 1. X and y cannot multiply each other, and x, well, neither x nor y can be in the denominator. Because if you're in the denominator, I forgot to tap. If you're in the denominator, what that means is that your exponent is actually a negative. Okay, so that's what that means. So x and y, the exponents have to be 1. You can't multiply the x and the x and the y cannot be in the denominator. Those are the 3 conditions. If those 3 check out, then it would be linear. So questions on this as to why this one is not linear? And I think that's what a lot of these are probably going to start doing here. Those are the 3 things. Exponents 1, don't multiply the variables, and no variables in the fraction, in the denominator. No variables in the denominator. So let's see what they got. Okay, so the other thing they want you to do is they want you to find the intercepts. They want you to find the intercepts. And just a quick refresher, when we talk about intercepts, what we mean is remember you have your big old plus sign, you have your x-axis, and you have your y-axis, okay? And you have a line, whatever the line is. Let's do something like this, okay? Okay. Notice it crosses. There's points where it hits the x and the y-axis. We call those. Well, let me do this. Let me make it a little more noticeable. Let's do this. So notice there's a point where it hits the x-axis and the y-axis. The point where it hits the x-axis is called the x-intercept, and the point where it hits the y-axis is called the y-intercept. X-intercept, y-intercept. Those are the points where it hits those axes. Now, so the x-intercept is where the line crosses the x-axis. What's the value of the y when you're crossing the x-axis? What's the value of the y when you're crossing the x-axis? Do y'all remember? It's from the prior lesson. Just a quick review. In this scenario, the y value, because remember, it doesn't move up or down. It stays on that x-axis. No movement up or down. The y value of the x-intercept is 0. So the x-intercept is the point where it crosses the x-axis. But because it's on the x-axis, it doesn't move up or down, meaning the y component, the y value of the ordered pair, is 0. Similarly, the y-intercept is where the line crosses the y-axis. But in this case, the x value is 0. The x value of the y-intercept is 0. Why is that? Because when you go up the y-axis, you just move up the y-axis. You don't move left or right. You don't move left or right. You're just going up the y-axis or down the y-axis, whichever way. Those are things you're probably going to want to write down and memorize. The y-intercept crosses the y-axis, the x value is 0. The x-intercept crosses the x-axis, the y value is 0. So with that in mind then, now we take a look at this. They want us to find the intercepts of this equation. How are we going to do that? Well, the way that we do that is we're going to pick a value for x and pick a value for y. What value? Well, the y-intercept is the value you get whenever your x value is 0. That's what this says right here. When the x value is 0, you get the y-intercept. So basically just take 0 and plug it in for x. Take 0 and plug it in for x. And then solve for y. So the y-intercept is when x is 0, plug 0 in for x, and solve for y to find the y value of the y-intercept. So in this case here, what's that y value? When I plug in 0 for x, I solve, I solve it. So what does this give me right here? 4 times 0 is 0. So 0 equals minus y. And then I divide both sides by the minus 1. Get rid of the negative. So divide by negative 1 to both sides. And so what does that give me for my y value? Y is what?
1.
Try to calculate 0 in the numerator. Try it out. 0 divided by negative 1 gives you 0. Sorry, I almost said something else.
0.
So in this case over here, it's 0. So funny enough, this is actually both the x and the y-intercept. It's the same point. It crosses, this line here crosses through the origin, just like this. I try to cross it through the origin. It goes straight through the origin where that goes through 0, 0. So it happens, that's the point where it's the same thing. So that's what you would put in this one right here, 0, 0. Okay, so this is the lesson here. That's the main thrust of the lesson. The x-intercept is on the x-axis, y is 0. The y-intercept is on the y-axis, x is 0. That's the takeaway. That's the main thing. So when we do that, let me try similar. Let's see if they give us, okay, so it's the same thing in this one, but it's the same thing. Let's see if they'll probably give us another one here. So it's just more of the same now, but I think they're going to do another intercept question, and we're going to do more intercepts. This isn't the last time you're going to see intercepts. Intercept is like one of the biggest things that we'll learn. So you really need to know the intercept part of it all. So this one's asking us, is this thing linear? If it is, convert it to standard form. Or is it not linear? What do we say? What do we say? How do we find out? Well, remember the process. You got to simplify it. You got to get rid of your parentheses, combine like terms where you can. So when we do that, what do we get? Excuse me.
So we wouldn't be able to look at it and say the exponent's 2?
It is a quandary, and so I want to play around with it. So you're right. You're looking at it and you're saying, hey, look, I see some exponents of 2 there. Oh, yeah, I'm sorry. I'm seeing it now. Yes. Well, maybe. What do we got going on here? 5 plus y to the second power. How do we simplify that part?
Set up another parenthesis.
FOIL.
5 plus y.
So it becomes 5 plus y. It's 5 plus y. So you use FOIL. That gives you 25 plus what? 10y plus y squared. Okay? Do y'all see that part? This thing right here, 5 plus y squared becomes this. That's what you did on your last test. So let's make that replacement. Let's make that replacement, okay? So I'm going to type it now because my handwriting is getting a little bad tonight. So that's 25
Wait,
plus
hold on.
10y.
I have a question. Where does the 10y come from?
The outer, 5y times 5y. I'm sorry, 5y, 5 times y, outer. Inner, 5 times y.
Okay. Yeah. Okay. Now I get it. I was just wondering because I was
Sure.
like, where in the frick did he get a double number?
So this thing here becomes this part right here. Okay. So we got rid of the parentheses. Now, if we notice here, those y's are going to go away, right? Y squared minus y squared, the y squares go away. So what does this simplify to? 25 plus 10y equals negative 3x plus 10. Do y'all see how I got this? The y squares went away because they cancel with each other. Y squared minus y squared, they go away, leaving this part. Y'all see that? So at this point, can we look at this and can we determine whether it's linear or nonlinear? What would you say? Well, let's keep going. Let's keep going. And the whole point of it is what we need to do is we need to get the x, notice over here, to be in standard form means that the x and the y's are on the same side and then the constant terms are on the right side. So all your variables come to the left side of the equal sign. All your regular numbers go to the other side. So what do I need to do here in order to get it into standard form? Is I need to get this 3x term right here, I need to shift it over to the left side. And what else do I need to do? I need to get this 25 and shift it over to the other side. Okay, so I need variables to the left, numbers to the right. So it's just basically solving equations, your process for solving equations. So I'm going to add 3x to both sides. Okay, my handwriting's getting terrible, sorry. So I'm not going to do that. So let me do this. Yeah, here we go. So I'm going to subtract 25 from both sides, but I'm going to add 3x. Add 3x, subtract 25. So when I do that then, these 25s cancel. These 3x's cancel. That's the design. That's why we did that on purpose. Okay, so what do we get? This is 3x plus 10y. They're not like terms. We can't combine them, but we just leave them separate. So 3x plus 10y. And then on the right side, 10 minus 25. 10 minus 25 gives us negative 15. So what you need to do is you take your original equation, get rid of your get rid of your parentheses, move all of your variables to one side and all the constant terms to the other side of the equal sign. And that's what we did here. That's what we got. So now we assess 3x plus 10y equals negative 15. Is that linear or not linear? 3x plus 10y equals negative 15. What would you all say?
I would say yes, because there's no exponents higher than 1.
They're not multiplying each other, and the variables are not in the denominator. Right.
Right.
I agree. Yeah, it's linear. Linear. So the gist is, as we go along, they just get a little more challenging. But it's the same story. To determine whether it's linear or not linear, you have to get it in. You have to get the variables to the left side, get rid of your parentheses, and move the terms so that the variables are on the left side of the equal sign, and all the constant terms are on the other side. And then you can assess exponents one, not multiplying each other, not in the denominator. Check, check, check. So yes, it's linear. Okay, so that's that one, and I think we're going to have another. Good. This is what I wanted. I was hoping for it. So we're going to have something like this. Now, after this lesson, you're not going to have it that complicated anymore, for the most part. Sometimes, but not. That's not the routine thing. So this one is linear, by the way. This one is linear. So what they want us to do is they want us to find the intercepts. So remember what we do is basically the intercept, the x-intercept is what? The x-intercept is when y is 0, and the y-intercept is when x is 0. So essentially what we do is you're just plugging in 0 for the variables. Okay, so you plug in, so to find the x-intercept, plug in 0 for y. To find the x-intercept, plug in 0 for y. So come over here. So we come up to the original equation, plug in 0 for y, and then solve for x. Solve for x. So 7 times 0 goes away, leaving negative 3x equals negative 3 times negative 7 is x. Now we need to solve for x. Solve for x. So we got to get rid of the print. So then you, for this part now, you just fall back on your process from all the way back in the second week class of solving equations. Get rid of the variables. Get rid of the variable. I'm sorry, the parentheses. Get rid of the parentheses. So multiply the negative 3 inside, so that gives us 21 minus 3x. Now we need to add 3x to each side to get the x over to the left side. Uh-oh, what happens?
They both cancel.
Yeah, the x is canceled too. The x is canceled too. So what does that mean? What does that mean?
The answer is just 21.
Well, let me ask you it this way. Is 0 equal to 21?
No.
So there is no solution to this. There is no x-intercept. There is no x-intercept. This thing here is a false statement. False. False. 0 is not equal to 21. False. Meaning the 0 we plugged in for y right there is not, it doesn't ever work because it results in that. So in terms of the x-intercept, because that's what we're looking for, we plugged in 0 for y, which means we were trying to find the x-intercept. It is absent for this particular one because the x's went away too. When we plugged in 0 for y, it just so happened the x variable went away as well, meaning there is no x-intercept. There is no x-intercept. But what about the y-intercept? What do? Well, same thing. Same thing. We got to plug in 0 now for what? Plug in 0 for x. Plug in 0 for x. So negative 7y minus 3 times 0 equals negative 3, negative 7 plus 0. Now we solve for y. Okay. So on the left side, the negative 7y remains, but the 3 times 0 becomes 0 and goes away. Okay. On the right side, the negative 7 plus 0 becomes, well, I clicked too soon. This part becomes, nards. It's not gonna let me do it. Okay, let me do it again. I clicked my thing too soon. Okay, so negative 7y minus 3 times 0 equals negative 3 times negative 7 minus 0. So on the left side, 3 times 0 goes away, leaving the negative 7y. In the parentheses on the right side, negative 7 minus 0 just becomes negative 7. Do the multiplication now on the right side. Negative 3 times negative 7 becomes positive 21. Divide both sides by negative 7. and we get -3 for y. So notice this one does have it does have a y-intercept. The value is -3. So it is possible to have it's possible to have a y-intercept but no x-intercept, and we'll see one vice versa. You can have a line that has no y-intercept but has an x-intercept. So the questions on this one. The process for finding the intercept. If you're finding the x-intercept, plug in 0 for y and solve for x. If you want to find the y-intercept, plug in 0 for x, solve for y. That's what the two processes here. We plugged in 0 for x over here, and we plugged in, oh, I'm sorry, wrong one. We plugged in 0 for y over here, and then over here we plugged in 0 for x, and then solved respectively. If you get a situation like this where the variable happens to go away, that means there is no intercept, that particular intercept. But just because you don't have one intercept doesn't mean that you can still have the other intercept. It's still fine. So the big takeaway here, there's a couple of things, but the big takeaway is the process. To find the intercepts, to find the x-intercept, plug in 0 for y, solve for x. To find the y-intercept, plug in 0 for x, solve for y. That's the main process. The other takeaway from this problem is, if in the course of things, like this one right here, your variables go away, whatever intercept you were trying to find doesn't exist. Don't have it. That's the other takeaway. So let me stick with this one then. Let me scroll down a little bit. This one did not have an x-intercept, but the y-intercept was 0, -3. Okay? What does the line look like? What does the line look like when it has a y-intercept but not an x-intercept? So this is the x-axis, this is the y-axis. So what does it look like when a line crosses the y-axis but never crosses the x-axis? In order to do that, my line, so it goes through -3. So this line can never cross that horizontal line. Never cross it. So if a line never crosses another line, that means it's parallel.
Parallel.
Right. And so this is a scenario. This is what happens. This is what it looks like in a graphical, in a pictorial sense. A line that doesn't have an x-axis but has doesn't have an x-intercept but has a y-intercept, it's a horizontal line. A horizontal line. Because it never crosses that x-axis. It's parallel to it, so it's horizontal. And it's any horizontal line would be that way. And vice versa. Vice versa. What is a line that has an x-intercept but not a y-intercept? It has an x-intercept but not a y-intercept, so it never crosses the y-axis, meaning it's parallel to the y-axis. Oh, it's a vertical line. So a vertical line is a scenario where you have an x-intercept but no y-intercept. So that's what it sort of looks like. That's why you can have one but not the other sometimes. It's coming at you. It's a lot of different things. It's all kind of mixing up together. But the big takeaway is still the fundamental takeaway. To find the x-intercept, plug in 0 for y, solve for x. It's the point where it crosses the x-axis. The y-intercept, plug in 0 for x, solve for y. That's the point where it crosses the y-axis, the vertical axis. All this other stuff is just sort of a consequence of those two basic properties. Questions so far? The big takeaway on this one is putting it in standard form and finding the intercepts. Okay. So here we go. You talk me through this one. 4y minus 5x equals negative 30. Let's find the x-intercept first. The x-intercept first. How do I find it?
We plug 0 in for y.
Right. Plug 0 in for y, and now we solve for x. So 4 times 0 goes away, leaving negative 5x equals negative 30. So what does that mean that x is equal to? Divide both sides by negative 5. So negative 30 divided by negative 5. Don't forget about your calculator. And negative 30 divided by negative 5 is positive 6. So the x-intercept as an ordered pair, is what? 6 comma 0. The 6 is the x value. The y is 0 because it's an intercept, the x-intercept. So, oh, whoops. Yeah. So we put in a 6 here and a 0 there. Let me pause. Questions on that part? On finding the x-intercept. So now let's come over here. Now I want to find what's the y-intercept. How do we do that? How do I do that?
Put 5 times 0.
Plug in 0 for x.
4 times, yeah.
Plug in 0 for x. Solve for y. And I'll do this one. So we divide both sides by positive 4. So negative 30 divided by 4 gives me negative 15 over 2 or 7.5, something like that. But we would say negative 15 over 2. So the xy ordered pair would be what? An x, it's a y-intercept, so the x was 0, and the y value of the y-intercept is negative 15 over 2. So that's it. That's the thing. The big takeaway. How do you find the intercepts? Plugging in zeros for the variables. Good. Feeling good on that? And now I think from here, after this part, it's just more of the same. Just more of the same. So let's press forward and let's see. I think it's just more of the same now. Okay. So now it really is just more of the same. Determine if it's linear. If it's linear, put it in standard form. This is almost identical to the last one we did. You have to simplify the exponent by doing the FOIL method. Get rid of the parentheses by applying FOIL. Combine like terms. Get your variables to the left, regular numbers to the right, and see if it's in linear form. So that's just that's a repeat of one we did earlier. Finding the x and the y-intercept. So really it's now just a rehash. Okay, so that's that one. Section 2.3, the big things, the takeaways. How do you find the x-intercept and the y-intercept? What does it mean? And then 2, how do you identify if an equation is in linear form? And how do you write it in standard form if it is linear? Those are the 2 big takeaways there. So now we get to start on the next one, sort of building on process. So that was 2.3. Now we can start on 2.4, which is good because we need to be able to start on it. We're not going to make it through tonight. We're going to start on it tonight, do this, and then work on the rest of it on Thursday. So look at the title, by the way. It says slope and the forms of linear equation. The forms of linear equation. Before we get started on this, let me go back to something I mentioned earlier. There's the form of the line called the slope intercept form. The slope intercept form. Hey, you've heard the word intercept. Intercept. That form is of a special form called y equals mx plus b. In this form, the m is the slope and the b is the y value of the y-intercept. Okay? We've talked about standard form. Standard form is when x and y are on the same side of the equal sign. This is a different form, a special form called slope-intercept. And the reason it's special is because when you have an equation in this form of y equals mx plus b, it gives you the value of the slope in the y-intercept. So I'm not going to do this problem yet. But what I'm going to do is, so suppose we have the equation y equals 2x plus 1. What's the slope? What's the y-intercept? Okay. So how do I do it? How do I find it? How do I find it? Well, the thing you need to take note of is what? The m, okay, whoops, won't let me do it. The value, when you have it in slope-intercept form, the value in front of the x is the slope, and the value on the end without a variable is the y-intercept value. So in this one right here, what's the value of the slope? What's the value of
2.
the slope? It's the 2. It's the value in front of the x, right? So the slope, and we're going to label in this lesson, when you're dealing with equations of lines, two variable equations, m means slope. So right, the m is 2, and what's the b value? It's the one without the variable, meaning the b value is 1. So how do you know if your equation is in slope-intercept form? What's the defining feature? The y is by itself. Get the y by itself, then it's in slope-intercept form, because the x and everything else is on the other side of the equal sign. To get something in slope-intercept form, you get the y by itself. That's the key to the whole thing. So let me go to a whiteboard. Okay, so given the equation y equals negative 3x plus 4, what's the slope? What's the y-intercept? So in this case here, what's the slope for this one? You ask yourself, is it in slope-intercept form? Is it in the form y equals mx plus b, meaning is the y by itself already?
Yes.
Yes. So we can just read off the slope. If it's in slope-intercept form, then you just read off the values. You line it up and say, oh, the slope, the m value, is the value in front of the x. So the slope in this case is negative 3. And the b lines up at the end. Okay, so the b in this case, the y-intercept is 4, b equals 4. So that means the y-intercept, the xy ordered pair of the y-intercept is what? Well, remember, if it's a y-intercept, where's your 0? Is it in the x or the y? It's in the x. So the y-intercept is actually 0, 4. That's the ordered pair associated with the y-intercept. but it stems from the fact that the b value is 0. So what this slope-intercept form tells you is it tells you two pieces of very critical information, which we're going to see why it's critical in a few moments. But when you get the y by itself, that tells you what the slope is and tells you what the y value of the y-intercept is. The y value of the y-intercept. And just remember, the y-intercept is an ordered pair, x comma y, where x is 0 because it's crossing the y-axis. Crossing the y-axis. So that's what x is 0. So it's sort of a convergence of different concepts. But let me pause here. This is the slope-intercept form of the line. Tells you the slope, tells you the y value, the y-intercept. Any questions on that? So let's change it up a little. Suppose I have this. Given the equation 2y equals 8y plus minus 2. What's the slope? Oh, well, I'm sorry, not 8y, 8x. 8x. 2y equals 8x minus 2. What's the slope? It's a trick question. It's a trick question. To be able to find the slope, the equation has to be y by itself. In my equation, 2y equals 8x minus 2 is the y by itself. The answer is no. There's a 2 in front. We can't have that 2. The y, it can only be a y, nothing else. No values, no nothing. So what we're going to do is we would take, my pen will show up. We take the 2y. Oops, hold on. Didn't give myself enough room. Take your equation and you got to solve for y. How do I solve this for y? Well, 2y says 2 times y, so I do the opposite and I do it to both sides. Whenever you're solving, solve means do the opposite, do it to both sides. So I got to do the opposite of multiplication, which is division, but I divide each term by that same value. Divide each term by that same value. And so then it gives me what? The 2y over 2 cancels down to a y. 8x over 2 is 4x. And then minus 2 over 2 is a 1. Now my y is by itself. That's what I need. That's what I need. So then, what's the slope? What's the y-intercept? What would you all say?
4 would be the slope.
Say it again.
4.
4. And what's the y-intercept?
Would it be -1?
Mm-hmm. So that's
Zero.
the
Zero.
y value. So the actual ordered pair is 0, -1. This is just the y, but you got the -1. That was the other thing I just quickly threw in there, testing you all on negatives just to kind of remind you it's always going to be around. But good, Jenny, you passed my test. So that's the key. If you want to get in a slope-intercept form, it's wonderful because you can see the slope. You have to have the y by itself. Have to have the y by itself. Okay. We're going to come back to this. We'll do more on this. I just kind of wanted to get this thing. But the thing I didn't tell you is what? What does it mean to be a slope? What does it mean to be a slope? And think of it this way. The slope is just, oh, here's the definition. I'll give you that. Oops. The slope measures the steepness of a line. The slope just is a measure of the steepness, okay? So uh, uh, a steep slope, a high value would be a steep slope. A low value like 0 would be a small slope. So it just measures the steepness of a line, the steepness of a line. So so that's what we're trying to find. Is we're trying to find that steepness, trying to find that measure the steepness. Um, a Let me give you some other rules here to kind of a slope of 0 means is a horizontal line, and undefined slope is a vertical line. Is a vertical line. A slope, so when it's flat, that's a 0 slope. That's a horizontal line. If it's completely vertical, like a wall, a cliff, that's a vertical line. That's an undefined slope. We'll see why it's 0 and undefined in just a second, but those are sort of the consequences. So everything else is fine to have. But 0 slope is horizontal line, cliff, side of a mountain, the side of a cliff is a undefined slope because it's a vertical line. Okay, so what this question here, this first question, tests upon and focuses on is how do we calculate the slope given two ordered pairs like this? We've already seen when you have the slope-intercept form of the equation, y equals mx plus b, we can see the value of the slope. It's right there in front of the x. But sometimes they give you a problem like this where they only give you two ordered pairs and they ask you to find the value of the slope. So how would we do this? There's a couple of different ways to go about it. A couple of different ways. So let's just sort of let's reset our mind, okay? Let's keep in mind what we're doing. Let me put it as a picture. That's funny. Let me put it as a picture. So if I'm going to plot the ordered pair -6, 8, which quadrant is it in? Quadrant 1, 2, 3, or 4? Quadrant 1, 2, 3, or 4. How do we know? Well, you got to kind of go to your rule. You can graph it. So that's -6. That's 6 to the left, 8 up.
Quadrant 2.
Yeah. So it's kind of like over here. It's kind of like over here. Okay. So I'm going to label that one. So that's one's -6, 8. This one here is -6, -2. It's 6 to the left, down 2. So that one's like right here. What's the slope of the line that connects them? Oops. What's the slope of the line? What kind of line does it make? Vertical line. The slope is what? Undefined. Why? Because the line is a vertical line. Do y'all see that?
And it's vertical because it didn't cross the y-axis.
Right. But we can see it a different way. Look at the x values. Look at the x values. They're the same. They're each -6, meaning they're lining up in a straight line. But to your point, Jana, yes, as well. This line is not going to cross the y-axis, so it is a vertical line. Good. So when your x's are the same, you're dealing with a vertical line. So it's undefined in this case. That's one way to sort of analyze it and see what you're dealing with. Okay. But there's another way. Suppose you don't really like the graphing. Um, it's sometimes a little too arduous. Okay. How can we find it another way? And this alternative way actually goes to the heart of why is the value of the slope of a vertical line, why is it undefined? Why is it undefined? Why isn't it a value? Why isn't it something? Why does it have to be undefined? That's what we're going to show you. That's next. And it helps to do this calculation as well. So if you don't like to graph, this is the way you would want to do it. So there is a formula. There is a formula. It's called the slope formula. To find the value of the slope, m, the m value, you make a fraction. And the numerator of the fraction is y2 minus y1. And in the denominator of the fraction is x2 minus x1. Okay, that's the formula. What does it mean? It means the numerator, take the y values and subtract them from each other. The two y values, the first y value and the second y value. That's all it means. That's y2 minus y1, second minus first y value. And the same thing with the denominators. Take the x's of the ordered pairs and subtract them with each other. So what you do, what I do at least, is I label my values. Label the first ordered pair you see, x1, y1. Label the second ordered pair you see as x2, y2. Could I have switched it? Name the first one x2, y2, name the second one x1, y1? Yes, you can. Doesn't matter. You just need to be consistent. The x1, y1 is the first ordered pair. The x2, y2 is the second ordered pair. That's all we need. So when we see this then, what do we have? What does this mean, by the way? When we have this sort of setup, I'm going to actually write it out now. x1, what's the value of x1 that I've set it up as? What do y'all see it? If I'm going to label the ordered pairs x1, y1, x2, y2, that means that the
-6.
yeah, -6. Good, good. What's the value of y1?
8.
8. What's the value of x2?
-6.
-6. And what's the value of y2?
-2.
So what I do is I actually just I actually list them out. What are the values I'm working with? You know, it helps. So now, where am I at? Right here. Yeah. Now you take these values here and you plug it into that formula.
Okay.
So
So
the top is the difference of the y values, y2 minus y1. So that's y2 is -2 minus y1 of 8. So -2 minus 8. The denominator is the difference of the x2 and x1. So x2 is -6 minus x1, which is also a -6. So notice there are two minus signs. Why? Because the middle minus sign comes from the formula x2 minus x1, and the second minus sign comes from the fact that we have defined x1 to be a negative value. Once you fill in the values into the formula, simplify the fraction using the order of operations. So I want to come over here. -2 in the numerator, -2 minus 8 is -10. And the denominator, -6 minus -6. What does that give you in the denominator? The two minus signs cancel to give you plus. So this becomes -6 plus 6, which gives us what? What does that give you in the denominator? Do it on a calculator if you need to.
0.
0. Now I really want you to do it on your calculator. What is -10 divided by 0? Everybody punch it into your calculator and see for yourself.
But when you calculator or the phone?
Say it again.
0.
Check your.
it says error.
Remember, the fraction is numerator divided by denominator, top divided by bottom. So you type it in, -10 divided by 0.
It's undefined.
Undefined, you get an error. It won't do it. That's why it's undefined. That's why it's not a number.
Oh, so
It's
you put
not
the
here.
Zero, there's a zero in the denominator. We can't
That
have
right
that.
there.
We can't have that. So the takeaway, there's a couple takeaways here. Let's step back and we'll do more. We'll do more.
return that to school or use that for your test.
What?
What you doing?
This one on notes.
Okay, so there's a couple takeaways here. One is uh, the slope measures the steepness of a line. Okay, zero slope is a horizontal line. A cliff, a vertical line is an undefined slope. Why? Because when we plug in the slope formula, that's the second takeaway. Slope m is y2 minus y1 divided by x2 minus x1. Plug in the values, order of operations, you get the fraction, something over zero. The zero in the denominator is why it's undefined. We can't have that. That's it becomes undefined. So we're going to do more calculations like this, seeing how to do the slope formula and how it sort of corresponds to different values of slope. Any questions on this one? Excuse me. Hold on just a second, folks. Hold on just a second. I gotta do a text. Sorry about that. Okay. So let's, any questions? I don't think I heard any questions. Are we good? Okay. Let's go forward. Let's see. Okay, so here's another one. Find the slope of the line that passes through the following points. When it says points, they're talking about ordered pairs, okay? Talking about ordered pairs. So how are we going to do this? We don't have our line, okay? You could graph this if you wanted. You could see the orientation and sort of figure it out from there. That's fine. But let's practice using the formula. Remember what the formula is. M equals y2 minus y1, all of that over x2 minus x1. Next step, label your values. These are two ordered pairs right there. When they say points, they mean ordered pair. It's the same thing. Okay. So remember they're of the form x comma y, but this is the first ordered pair x1. This is x1 y1. This is the second ordered pair x2 y2. And so I list out my values so that I know what I'm dealing with. X1 is 6, Y1 is 8. Do y'all see that? It's the X and Y value of the first ordered pair. That's what the ones and the twos mean. X2 is negative 11, the X value of the second ordered pair, and Y2 is 8. It's the Y value of the second ordered pair. Now we take those values and plug them into the slope formula. So Y2 is what? 8 minus y1 is also an 8 divided by x2 is negative 11 minus x1 is 6. What does that give me? What does that fraction become? 8 minus 8 over negative 11 minus 6. What's the numerator? What's 8 minus 8?
Sorry,
Zero.
0. I was saying it was on mute. I didn't realize.
0. What's negative 11 minus 6 in the denominator?
Negative 17.
Negative 17. What does that fraction simplify down to? Use your calculator.
0.
0. So what are we dealing with? If we get a 0 slope, what are we dealing with? If we were to plot this out, 6, 8. So let me do the ordered pairs. 6, 8 is right here. A negative 11, 8 is over here, and we connect the dots. What shape is that?
Horizontal. I mean,
Horizontal line.
horizontal.
Horizontal line has a slope of 0. That's why it becomes 0, is because the y values are the same. If you look at the y values were the same. So when the x values are the same, it's a vertical line, undefined slope, because 0 is in the denominator. When the y values are the same, it's a horizontal line, because it creates a horizontal line, so it's a 0 slope because the numerator is 0. Questions on that? All right. We're going to pause. We'll pick this up tomorrow. Finding the slope is a big deal, because once you can find the slope, you can pretty much do anything at this point. This is the gateway. Knowing that the slope-intercept form, y equals mx plus b, being able to identify the slope there, and then also calculating the slope, y2 minus y1 equals x2 over x2 minus x1. That's another big deal. The rest of it, we're going to start putting it all together. Okay, that's what we're going to do on Thursday. So give you a little mental break on that.
I do have a quick question before you raise that. Where it says simplify your answer. So what will we actually put in the box? 0?
0. Mm-hmm.
All right.
Yeah, that's just the value. That's it. That's simplified.
Okay.
Basically, they're saying if you can write it as a simple number, reduce your fraction.
So let's just say it was
2/3, negative 4/5. You would write it as a fraction.
okay.
0 is fine. You would want to write it as 0. But if it's a fraction like this, that's sometimes what you're going to see, some things like that. These are special cases, by the way. Vertical and horizontal line, those are special cases. Most of the time you're going to have a fraction like 1/3 or negative 2/7 or something like that. Most of the time you'll have that. They just happen to give you the two special cases right off the bat.
Okay.
And that's why I wanted to do those, because now the rest of the discussion is going to be the more generic cases. Okay, so what we're going to do is kind of go back, do a little quick review, a couple problems, just so that you can kind of get the juices going again, because it's been some time. Is what? Let's go back and take a look at, where are we at? We did quadratic. Radical? Okay, let's see a radical and let's see a rational. A radical and a rational. Of the type that I'm probably going to give you. Okay. So we're going to go back to 2.R.9. And this is a pretty good one here. So the radical equation I'm probably going to give you is where you have just one radical. Okay, I'm not going to do the scenario where you have two radicals and all that stuff. I think that's just overly confusing. It doesn't serve a purpose. Because the other problems you have with radicals, like the quadratic formula, only has one radical. It doesn't make a whole lot of sense to give you these overly complex ones. That's a philosophical thing. So when you have this, just remember when it says, remember the directions. Look at the directions. It says solve. So what does solve mean? It's the same two steps. do the opposite, do it to both sides. We've seen the key is what scenario do I have? What's the opposite? So here, when you have a radical, a square root, what's the opposite? And you would say? What's the opposite of a square root?
Squaring it.
Squaring it. Square root and square cancel each other out. They annihilate each other. So that's the process. Do the opposite. Well, we have a square root. Okay, we need to get rid of it. We need to get rid of it. So we do the opposite. So you square both sides. Okay. Now by squaring that left side, the square cancels with the square root. And you just pop that middle part out. -8 minus x. And the right side, you would actually just then do the square. So what's 1 squared? How would I simplify this? 1 squared.
1 times 1, which is 1.
Which is 1. So boom, there it is. Now we have this. This is what's left. -8 minus x equals 1. Now you kind of, it takes you back to what you did all the way back in week 2. Solve for x. Get the x by itself now. When it says solve, it means it wants the x by itself. So what's the solution become? What would you all say?
Negative x equals 9.
Negative x equals 9. So how'd you do that? Oops.
I added 8 on the left side and added 8 on the right side.
Boom. So what does that mean that x is equal to?
Negative 1x.
Sure. It is negative 1x. So what does x become? We got to get rid of that minus sign. How are we going to get rid of that minus sign?
You're going to divide by -1.
Because remember, negative x, or also known as negative 1x, means negative 1 times x. Do the opposite. Means we divide. Divide by -1. Divide by -1. So 9 over -1. And if you ever get stuck, on your calculations, calculator time. That's the solution.
-9.
X equals -9. Mm-hmm. Questions on that one? That's pretty much like what I would give you. Because I want you to recognize that when solving radicals, the opposite is squaring both sides. That is the opposite. That's the key to the whole thing. I don't think I'm going to give you another. Same thing. Same thing, pretty much. Yeah, okay. So then, let's take a look at our other one. Where's it at? Rational. Is it this one? Well, let's do multiplication division of rational. This would be something you would be expected to do. Something sort of like this. Okay, probably something like this. Well, let me see. I just really get kind of wild with these. Okay, this is good. This would be good. Okay, so when we say rational expressions, think fractions, ratio. If I don't think I ever did this with you all, but the first 5 letters of the word rational is ratio, and a ratio is a fraction. Okay, that's the giveaway. Okay, so what do we do though? What do we do? What are we trying to do? We are multiplying. In this case, we're multiplying. the two fractions. So how do we multiply? Well, multiply straight across. But the fact that we have polynomials here, really what you want to do first is you want to what? You want to factor. You got to factor. You got to factor. So you got to bring up all those things of factoring again. Remember GCF, difference of two squares, trinomials, grouping. You got to be ready for all of them. And that was the last test. You got to be ready for all. That's why I broke it up. So how am I going to factor the top here? Z squared minus 8z plus 15. What does it give me? Well, that is z, I'll do z minus 5 z. It doesn't like my z. Oh, you know what I'm going to do? I can't really do it. I have to do this. Z minus 3. That's the first fraction. All of that over z minus 6 times. Now we got to factor the numerator. The numerator of this one. 3z squared minus 14z minus 24. Well, I got to use my AC method. So this is going to become, I don't know. Let me see, 3z z. What is it? 8, 4, 6. Oh, there it is. I got it. 6 and a 4. That is 18, and that's 24. Good. So 3z plus 4 times z minus 6. All of that over z minus 5. So when you're dealing with rational expressions, you got to factor, pull it apart. Why? Because once you do that, you can take this thing here and cancel it with this thing here. Z minus 5s cancel with each other. What else can we cancel? What else can we cancel?
Z minus 6.
This thing here, z minus 6, right, cancels with this thing here. Oops. So cancel the z minus 6 with the z minus 6. All right, so now you've canceled the things that are in top and bottom, okay? That's when you now do your multiplying straight across, okay? That's when you bring it back all together, okay? Or you could do that before too. So that leaves us with what? Z minus 3 times 3z plus 4. And at this point, I would probably go and do the FOIL method. So to get rid of your parentheses. So let's say 3z squared. Let me change my color ink. 3z squared plus 4z, that's outer, minus 9z, that's inner, minus 12, that's the last. So clean this up. Plus 4c minus 9z is minus 5z. So this would probably be the answer I would do right here. 3z squared minus 5z minus 12. But the key to this one is factoring. Factor the top and bottom so that you can cancel out some factors. And be prepared. Let me take this down. Suppose this thing here was a division symbol. Suppose it was division. What would I have to do? How would that change the process?
You would put everything on the bottom on top and the top on bottom.
Which one though? Both fractions
Yeah,
or only one of the fractions?
both.
Let's do an analogy. Suppose I have 3/4, oops, and I divide it by 7/8. When we divided regular fractions, which one did we flip? Just the right one.
Okay.
Just the right one. The left one stayed alone. Same thing. If you have a division, you just flip that right one. That's it.
Only the right
And
side.
then after that, factor, cancel out your common factors.
Okay.
Let me find one more along these lines. So here's one, but let me do something not so arduous. Let me go back. Here we go. So let's do this one. 21s divided by 6t to the third divided by 7s over 24t to the second. It's division. So what are we going to do?
Flip the second.
Flip the second. So that
7s over 24t squared.
so it becomes 21s. Pretend that this is an s, not a 5. S over 6t to the third. Change that division to multiplication and flip that second fraction. That's right. So it becomes 24t to the second over 7s. Now what?
Factor it.
Factoring typically is done when you have plus and minus signs, polynomials.
Mm.
Here we don't have that. So, I mean, you could do some factoring if you wanted, but you don't need to. I would probably go ahead and just, let's bring it together into one fraction. So remember, you multiply straight across. That's how you multiply fractions. Excuse me. And so what does that give us? So let's just write it as 21s times 24t to the second, all that over 6t to the third times 7s. Can we do any canceling? Can we do any canceling?
Can we cancel the s's?
Yep, I like it. Cancel some s's. So this s here cancels with this s here. Okay, what else?
I feel like, can we cancel one of the t's?
Not just one. How many t's do I have in the top?
2,
T squared means 2t's, right. How many t's do I have in the bottom?
3. Oh,
3.
so we could get rid of one of them.
Yeah, you can get rid of 2 of them.
2 of them, yes.
TT,
One.
TTT. So remember, that's really the quotient rule. Okay, you can apply the quotient rule. But if we think about it, how many t's are in the top and bottom? There are 2t's. So I'm going to cancel 2t's here. And
Okay.
when I cancel 2t's from the t3, when I take 2t's away, how many t's am I left with in the bottom?
Just the one.
Just the one. So it's going to change this 3 to a what?
Just nothing.
An exponent of 1.
Okay.
So we're going to cancel just the exponent. It leaves an exponent of 1. So we're left with a t. We're left with 1t. All right, how about the numbers? Can we cancel? Can we simplify the numbers? So here's what we have. Sometimes you need to clean it up a little bit. So you have 21 times 24, okay? S and T are gone from the top. 6t times 7. So give yourself a little space to clean it up. because sometimes handwriting gets a little bad, a little funky. I speak from experience on that one. Handwriting is very bad. So, can I cancel? What about the 7 here? I can cancel it with the 21, right? What's 21 over 7?
3.
Leaves me a 3 behind. How about the 6? I can cancel it with the 24. What does that leave behind?
Even though it's not the same variable? I mean, it's not the same.
Well, the t is left behind.
Okay.
And in the top, it becomes 3 times 4.
4, so t equals 12.
Not
Oh,
t equals
these at the
12,
bottom. Okay.
but the 12 over t.
Okay.
It's just the process of simplifying fractions, canceling stuff from the top and bottom. Questions? All right, so you'll see the test a little later today, but it's pretty much factoring. It's basically taking all the rules you did in test 2 and applying them now. Simplifying fractions, but your process for multiplying polynomials, the product rule, the quotient rule for simplifying fractions, that's all that stuff's coming in. Factoring to simplify expressions, using the factoring method to solve quadratic formula, things of that nature. So it's basically everything you did in your last test, and now you got to use it to solve these problems. Okay, so by the way, if you happen to be behind, that's okay. I'll keep the test open, but really do your best to catch up through this test, all that homework and through this test by this weekend, so that you can start catching up on the other stuff. Because I think once you start on the Cartesian coordinate, the ordered pair stuff, it's going to go quicker because it's probably a little, I don't want to say easier, but a little more relatable, if you will. Okay. Well, have fun. Have fun watching the news. I'm sure I got my app going. Who's got however many ever electoral votes. So we'll see. We'll see what the world looks like. I don't know if we're gonna know our results tonight or not. It's a whole new world with counting votes these days. It takes days. But anywho, hope you have a good night, and then we will catch up. So we're gonna do the test tomorrow. We won't meet tomorrow. We'll meet again on Thursday. Sound good? Alrighty, and I'll get this video loaded for you tonight as well. Alrighty. Well, good luck. Have fun. We'll see you in a couple days.
All right, thanks.
Alrighty. Let me get this cooking here.